See, we have discussed in the earlier class the concept of economics of power generation, various factors related to economics of power generation, and also how the cost of power plant will be analyzed. So for analyzing the cost of the power plant, we will consider the fixed cost and the running cost. Okay, so under fixed cost, all these things I have explained in the last class. So under fixed cost, see, we have the cost included for the land and the cost included for the building of the plant, and then also the interest that is considered for investing this amount. See, for building a plant, you might have taken some loan from various banks or funds. So interest has to be considered. So this is also considered under fixed charges. And then you have depreciation cost. That is any equipment or any asset, or here in our case it's a plant, as the years passes by, its value gets reduced. So some amount has to be kept every year. This is called as depreciation amount. So this is also considered under fixed charge. Okay. Then we have the wages and taxes, insurance, all this also considered as fixed cost. See, salaries has to be given for the staff, administrative staff, and even technical staff, all staff salary has to be given. So this is also considered as fixed charges. So then whereas running charges, so whereas for running charges, see the amount that has been spent for fuel, for example, if you have thermal power plant, for fuel forms the major part, is it not? So the cost incurred in fuel investment is nothing but the running charges. Even for lubrication cost, that is oil that is used for lubrication of various mechanical parts, that is also coming under running charges. So you have considered these in the last class, and you will be asked in the problems to calculate the fixed charges and running charges, and the total charges will be then sum of the fixed charges and running charges. So then once you calculate the total charges, you will be asked to calculate what is the cost per unit generated. You know that one unit means 1 kilowatt hour of power generated. Okay, so these type of problems we have solved. Okay, now this problem I had given as homework. Estimate the generating cost. So the maximum demand at the station we can assume as equal to the plant capacity. Since maximum demand is not specified, we will assume maximum demand at the station as the plant capacity, that is 50 megawatts. First, let us calculate annual fixed charges. That is, you know that interest and depreciation charges, wages and taxation charges will be added, considered as the fixed charges. Okay. So since here annual load factor is given, so we'll consider all this as for the annual fixed charges and annual running charges. Okay. So interest and depreciation is equal to given as 5% of the initial capital cost. You have to assume it is 5% of the initial capital cost. So that is why initial capital cost is 1.2 crores or 120 into 10 to the power 5. 1.2 crores is equal to rupees 120 into 10 to the power 5. So this into 5 by 100. So plus 6% is depreciation. So together we have done here. So these interest and depreciation, 5% and 6% of the capital cost, initial capital cost of the plant. So that's why it is this. Anyway, this value is common for both. So it has been taken out. And this is because percentage divided by 100. So you will get so many rupees 13.2 into 10 to the power 5 as interest and depreciation charges. Then wages and taxation. Wages and taxation, it is given directly in rupees. It is not given in percentage, whereas interest and depreciation is given as percentage of the initial cost, so that we have calculated, whereas wages and taxation is directly given in rupees, so that is rupees 4 into 10 to the power 5. So 4 lakhs is same as 4 into 10 to the power 5 rupees. So total annual fixed charges will be sum of these two, sum of the charges for interest and depreciation and wages and taxation charges. So you will get rupees 17.2 into 10 to the power 5. So we have calculated annual fixed charges. Next we will calculate annual running charges. So annual running charges you will calculate from the date of cost of fuel, lubrication and maintenance. It is given, it is 1 paise per kilowatt hour generated. Okay, so for that, to calculate this running charges, you should know, since it is given 1% of the kilowatt hour generated, so we should calculate the kilowatt hour generated. Okay, so here how do you calculate kilowatt hour generated? That is from the data of the load factor. Since load factor is given, annual load factor is equal to 40%. So since we have load factor is equal to actually average load divided by maximum load, or average demand by maximum demand, or average demand is equal to units generated per annum divided by number of hours in a year, because it is, since the load factor given is annual load factor. So annual load factor is equal to units generated per annum divided by number of hours, that is actually in the numerator, that will give the average demand divided by maximum demand. So this equation we have used earlier also. So since annual load factor is given, directly we can calculate the units generated per annum. So maximum demand we have assumed as equal to the plant capacity, that is 50 megawatts. See here, it is specified in megawatts, but since we want to express in terms of kilowatt hour, because 1 unit is equal to 1 kilowatt hour, convert into kilowatt. Okay, so this is 15 to 10 to the power 6 watts. 50 megawatts is 15 to 10 to the power 6 watts, or 15 to 10 to the power 3 kilowatts. Okay, so into load factor is 40% or 0.4 into hours in a year. 365 into 24 is 8760. So you will get directly, you will get in kilowatt hour. These are the units generated per annum. Okay, so you will get, after simplifying this, you will get 1752 into 10 to the power 5 kilowatt hour. Next, so now the cost of fuel, lubrication and maintenance etc. will be 1 paise per kilowatt hour generated. Like that you have to consider. So 1 paise, or if you convert into rupees, it is 1 by 100 or 0.01. So 0.01 into the total number of units generated will give the cost of fuel, lubrication etc. So here it is specified, you have to consider the cost of fuel, lubrication and maintenance, that is nothing but the running charges, equal to 1 paise per kilowatt hour generated. So what will be the total amount for cost of fuel and lubrication charges? So that is 1 paise into the total units generated. Okay, so here again we have expressed in rupees, so that's why 1 by 100, 1 by 100 is 0.01 into this, you will get rupees 17.52 into 10 to the power 5. So now total annual charges will be equal to sum of fixed charges and running charges, whatever you have calculated. So sum of this you will get rupees 34.7 into 10 to the power 5. So this amount is the total annual charges, which is sum of fixed charge and running charges. So this amount is required for generating the total units. Total units what you estimated is 1752 into 10 to the power 5 kilowatt hour. Whereas to calculate what is the cost per unit or per kilowatt hour, because here you are asked to calculate the cost per kilowatt hour. So whatever the total charges you have calculated divided by the number of units will give so much amount or rupees directly per unit, is it not? So you will get, actually this is what you get will be in rupees, directly it will be rupees, because it is total annual charges you have calculated in terms of rupees. You will get rupees 0.02. Since it is very small amount, you convert into paise. So 0.02 rupees or 0.02 into 100, that is 2 paise. So this is how you have to solve this problem. So we have calculated what is the cost per kilowatt hour. Okay, now So take another problem. A generating station has the following data. Installed capacity equal to 300 megawatts. Capacity factor equal to 50%. Annual load factor equal to 60%. Annual cost of fuel, oil, etc. equal to rupees 9 into 10 to the power 7. So directly here this cost is given in rupees. Sometimes they may specify as percentage of the initial cost. See, but here directly it is given in rupees. Here capital cost is equal to rupees 10 to the power 9. Again the initial capital cost is given rupees 10 to the power 9. Annual interest and depreciation equal to 10%, whereas see this is given in percent. So annual interest and depreciation is 10% of the initial cost. Like that you have to understand. You know that annual interest and depreciation is considered for fixed charge. Okay, this is given as percentage. So it is, that means 10% of the capital cost. Whereas cost of fuel and oil, they are considered as for running charge. Directly it is given in rupees. Okay. So with this, you are asked to calculate the minimum reserve capacity of the station and the cost per kilowatt hour generated. Okay. So here to calculate minimum reserve capacity of the station, see, you know that in every generating station, we will have a reserve capacity. In case if the load demand suddenly exceeds the units that is installed in the power station, we should switch on the reserve capacity. So here the reserve capacity will be equal to the installed capacity minus the maximum demand, or the installed capacity will be equal to reserve capacity plus the maximum demand. So installed capacity will be more than the maximum demand. Okay, so installed capacity equal to reserve capacity plus maximum demand. Okay, so you have to calculate this minimum reserve capacity of the station. Okay, so here we have to calculate, that's why maximum demand. Installed capacity is specified. To calculate the reserve capacity, we have to calculate the maximum demand. So maximum demand somehow we have to calculate from the given data. Since here capacity factor is given, load factor is given. So make use of this data. You know that capacity factor is equal to average demand divided by the installed capacity. And load factor is equal to average demand divided by maximum demand. But here installed capacity is given, average demand is not given. Whereas capacity factor as well as load factor is specified. So let us make use of these factors. So dividing 1 by 2. So that is the ratio of capacity factor and load factor will become equal to maximum demand divided by installed capacity. So after you simplify 1 by 2, you will get average demand will get cancelled. So maximum demand will go to the numerator. Okay, this. Next, or from this equation, we can write maximum demand equal to installed capacity into capacity factor divided by load factor. Installed capacity is given 300 megawatts. Capacity factor is specified as 0.5. Load factor is specified as 0.6. Actually, it is given in percent. When you are writing it, you have to write as this 0.5, 0.6. So directly you will get in megawatts, because here installed capacity you have substituted in megawatts. So you will get maximum demand in megawatts. So therefore reserve capacity is equal to installed capacity minus maximum demand. So you will get the value of reserve capacity that was asked in the problem. You have to calculate the reserve capacity of the station. Next, to calculate cost per kilowatt hour generated. So for this, like how you have solved in the earlier problems. So here we have to estimate the total annual charges, which will be sum of the fixed charge and running charges. So we'll calculate the fixed charges from the data. From the data with respect to interest and depreciation, this is considered for fixed charges, whereas cost of fuel oil will be considered for the running charges. Okay, so now first let us calculate what is the total generated per annum, because to calculate cost per kilowatt hour, we should know what is the total units generated or total kilowatt hour generated per annum. Since everything is here, it is given annual. So annual, so with respect to annual value, you have to consider hour, therefore hours in a year. So you have this equation, units generated per annum equal to maximum demand into load factor into hours in a year. Maximum demand you have substitute here, load factor 0.6, hours in a year, that is 365 days into 24 hours in a day. So total you will get 8760 hours. So what you get will be in kilowatt hour. See, you have to express this units generated in terms of kilowatt hour. So this has to be, demand has to be in kilowatts. So here you got maximum demand as 250 megawatts. That is 250 into 10 to the power 6. You convert into kilowatts. That is 250 into 10 to the power 3. Because we want in kilowatt hour. Clear? So you have got in megawatts, convert into, substitute here into in terms of kilowatts. 250 megawatts or 250 into 10 to the power 6 equal to 250 into 10 to the power 3 kilowatts. Okay. So that's how you have to understand this conversion, how we have substituted. So you will get 1314 into 10 to the power 6 kilowatt hours have been generated in a year. Okay. Now annual fixed charges is actually annual interest in depreciation. So that is given as 10%. 10% of the initial capital cost. You have to understand. So that's why 0.1 into 10 to the power 9. Capital cost is rupees 10 to the power 9. So you will get in rupees 10 to the power 8. Now annual running charges. Similarly, we have to calculate annual running charges. So annual running charges, it is given directly in rupees. If it were again given in percentage of the initial cost, you should have calculated, but it is directly given in rupees, 9 into 10 to the power 7. So directly you are taking. Then total annual charges is sum of fixed charge and running charges. You will get total annual charge. So this is the total charges required for generating 1314 into the power 6 kilowatt hour. But what is the cost per kilowatt hour? So this total charges divided by total units generated will give directly in rupees, because it is in rupees, or since it is small value, you convert it to paisa. So 0.14 into 100 is 14 paisa. Okay. So this is how you solve this problem. Okay.